All right. Hello, friends. Today I'm here to show you something that I've been working on for about the last 3 weeks, I want to say. This video is going to be for anybody that wants a better explanation for it than I can give off the top of my head. So, the creation I have made today, I have made a bit of a showcase platform to be able to show it in better detail. And, well, here it is. So, to get started, what I have made is I have made a basically a display connected to a transmission in its simplest form. What this display can do, however, is control anything I want to with a lot of customizability within this game or other games that can utilize Lua programming. And I wanted to have it all in one spot and a very modular creation that I can put into other creations, which we will get to at the end of this explanation. So for starters, this is what the basic module looks like. Just the black box you see here. I have taken a panel off so you can see the inside of it too. And you will see in greater detail what all of that does here in a minute. So if we turn it on, it has a explanation of what it is, how I made it, and a loading bar while it starts up. And this is the display itself. Now, of course, when this is placed in a creation, I have a vague idea of where I want to be sitting next to it. And I have made that right here. So if we hop in this seat, that's the same display as over there. Turn on the key, loads up, same display and everything. And this is what it looks like when you're sitting in a car seat next to it. What we have control of here is we have three sliders, this yellow, blue, and green, with letters above them differentiating what they are, and numbers above the sliders that give you the number output of what the slider is doing. So yellow is throttle power, so we have between 0 and 1 with every number in between it. We have the clutch pressure, which is between 0 and 1, which everything in between it. And then we have gears, which I can modify for whatever vehicle I need, but for the most part, I have it set to a 4-speed with neutral and reverse. So we start at -1, which is reverse, go to 0, that's neutral. You heard the click, that's it changing gears. Then we have 1, gear 1, gear 2, gear 3, and gear 4. And those can be switched between themselves at will, but the engine runs a lot smoother if you go up the path. Then, up here, we have fuel, battery, RPS, and temperature. Fuel is quite self-explanatory. It's just the fuel level of your vehicle in percentage. Battery is your battery level of a vehicle. RPS is rotations per second of your engine. And temp is the temperature of your engine. None of these are connected on this particular display, but in the next room over, they are connected, and I will be showing exactly what those do and how they work. So, let's move on to that other area. Come through this door. Here is a more laid out version of the display to kind of break down what everything does. So, as a quick explanation, we have a wheel up there that will kind of give you a visual example of the throttle and clutch working. We have lights over here differentiating which gear is currently active. We have over here, we have throttle and clutch pressure. We have this button, which is the brake for the wheel. The key button, which is the same as the key in there. And the display, which is the same as the display there. We have the battery for the vehicle. Behind here, we have the engine for the vehicle, which I will explain. And right here we have the microcontroller, which is where 99% of the work for the last 3 weeks has gone into. So, if we start the key here, as you heard, it automatically started up the engine and loaded up as you've seen before. And as you can see, we have 24 fuel, so 24% fuel in the tank back there. We have 0 in the battery, which is technically correct, because as you can see, if you hover over the battery, it's 0.9. And I do need to change that, but it's a very small detail, so I haven't worried about it. RPS is 4, so 4 rotations per second on the engine. And temperature is in Celsius, and that's 23 Celsius is the engine temperature current. If we come back here, here's the basic engine. This one was made specifically for this display, so it looks kind of odd. Have the radiator up here, and the fluid pump, that is the heating, or the cooling. So with this turned on, the cooling will stay lower than it would have otherwise. We have the engine engine fuel manifold, which gives fuel to the engine air manifold, which gives air to the engine, exhaust manifold, which takes exhaust out of the engine, catalytic converters, which reduce the smoke of the exhaust and the exhaust itself. Down here we have the starter, which obviously starts the rotation of the engine before it can do itself. And right back here we have the alternator, which will charge the engine as it's running. Down here we have the modular engine control unit, which I did not design myself, nor do I know how, but maybe someday. Let's see. If we come back around here, we can see the same display as we saw in the other room. The throttle. If you listen very closely, you can hear it running in the background. The higher up on the slider, the higher it runs. And you can see the RPS and temp going up as the throttle goes up. Alright. As you can see, the number up here go up as well. Same with the clutch. If we start the clutch, the wheel will turn because it is now getting power. As you can see, the number goes up and the throttle goes down because more pressure is being placed on the engine itself. It is also running in reverse right now. If we clutch all the way off, go up to neutral, up to gear 1, it will start going in first gear. Then clutch off, go to number 2. It will spin even faster, and so on and so forth. As you heard, the engine bogged down because we did not turn the clutch all the way off. And last but not least, gear 4. The wheel is now spinning as fast as it can. Now, if we turn the clutch all the way off, we have the button for brakes, which will stop the wheel entirely. Over here, we have the lights, so this is 4th gear. Then we have 3rd, 2nd, 1st, reverse, and neutral. Lights over here indicate which one is currently active. And as we change the gear, you can see that those will change. Alright. Now, to give you a quick explanation on a real vehicle, if we walk into this door, we see a truck that I have created. Not for this specifically, but this was part of my original plan, was to have a vehicle that this can be used in. So if we come in here, we have the same display, starts up the engine, loading up, and we have the same thing here. So we have 99% fuel, 0 battery, again, same thing, it's technically true. RPS of the engine, temperature of the engine, and right here we have a backup cam because it's such a large vehicle. So we have, same thing, throttle, which you can hear. Then we have the clutch. Then we have the gearbox. And this module is just the thing in the center. Everything else was made previous or after. And that this was the original intention, was to just have a module that I can place in the center of a craft or in the cockpit if it's a boat, bridge, whatever you say, to give me a basic control of all of the important aspects of the vehicle. To give another quick feature of the display, you see that we have two black boxes here, either of which can be customized to the needs of the particular vehicle, be that extra menus, extra warnings, maybe a backup cam if you didn't want a separate monitor for it. This right here, we have headlights. As you can see, it also activates the tail lights from the backup cam. And yeah, so that is a basic explanation of the outward appearance of the display itself. Now, let's return to the workbench. So you can see this in its all at once. And let's look at the inside of the display. So this is the logic of the display that I have built from the ground up. And I will be going through it for the next part of this video and explaining what everything does and how everything works to the best of my ability. Starting with, we're going to take a look at the inputs for the microcontroller itself. Everything that is connected externally to the microcontroller. So, if we look in this menu right here, we see everything that is connected to the microcontroller from the outside. And here's a quick rundown of what everything does. So we have RPS, battery, fuel, and temperature. All four of those are connected to particular parts of the vehicle or the display that we're currently looking at that will give the microcontroller basically the number that is coming out of those particular blocks. So RPS, rotations per second, is coming directly off of the crankshaft to tell us how fast is the crankshaft rotating in the engine / motor. Battery is coming directly off of the system's battery and is telling us how much charge we have in the system currently. Fuel is coming directly out of the fuel tank and is telling us how much fuel, like I said, in percentage, is currently in the vehicle. So, if you're on a long road trip and you need to know, do I need to go fill up with gas? This is how you tell. Temperature is coming directly off of the engine and is telling us how hot the engine is. It's not as efficient if it's hot. It's not as efficient if it's too cold, but it rarely ever gets too cold unless it turns off. Then we have system on. What this is doing, this is coming from outside, and it is coming from the key that you've seen me turn every time the display turns on. And that is telling the microcontroller that it is now on and it needs to start functioning. When it's not on, nothing is active and it doesn't take up any processing power for it to just exist on the vehicle. Throttle out and clutch out are outputs from the microcontroller, and they are going to the physical throttle and clutch of the vehicle. So the throttle out will go to the modular engine control unit, which you saw me explain earlier. Like I said, I didn't build it, but I do use it. and that will increase or decrease the throttle based on what the slider is on the display. Clutch is the same thing. It is not going to the modular engine control unit. It is going directly to the clutch, and it is telling it between 0% and 100% how hard to activate, how much pressure it needs to put on the clutch to spin the motor, or spin the wheels from the motor. XN and YN are not currently being used, but they are there for the capability of being able to use them from a GPS sensor elsewhere on the vehicle. The GPS sensor will give you the X and Y coordinates of where you are in the world you're currently in. And like I said, while it's not being used currently, what those will do is I can either show the coordinates directly on the display in a menu somewhere if need be, or I can put that directly into a map and show you on a map where you are. The touchscreen composite input is taking the touchscreen system from the display and putting it into the microcontroller to tell the microcontroller where on the screen I am currently touching, which is used for all three sliders extensively. And we'll get into that once we get into the specifics of the microcontroller. The next 6 here, reverse, neutral, first, second, third, and fourth, all go to their specific gearbox or clutch in case of the neutral. And they will basically turn on and off based on where the slider position is at on the gearbox slider specifically to basically output which gear needs to be currently active. You don't want first and third to be active at the same time. That's not quite possible on an actual transmission. In this game it is, so we want to make sure that doesn't happen. The last two, we have camera offset and to display. Camera offset is the same as XN and YN, to where it's not currently being used, but it's here for the capability of using it in the future. And all that is a direct input from a camera, say the backup camera, which you saw was on a different display. If I wanted it to be on this display, that's what that's there for, to be able to use it in the display itself rather than an external display as it's currently being used. Lastly is the to-display video output, which takes the graphics that is being produced inside the microcontroller and outputting them to the display to give us the sliders, the graphics, the numbers, the design, the little piece of art, the boxes, everything. Every colored pixel on that screen, that's what this outputs as. Okay, now that that is done, we can go to the specific logic, and I will give you a quick rundown of what everything does, and then we will go into the specifics of a few of them. So, for starters, if you remember at the start, we had the RPS, fuel, temp, and battery. Those are right here, RPS, temp, fuel, and battery, as you can read. And these are going into a composite write block. And what this is doing, this is outputting on channels 7, 8, 9, 11, and 12. So we have the RPS, temp, and fuel, and battery. Not quite sure why that's not connected. That's fine though. We have that all going into the composite write, and that is outputting on 7, 8, 9, and 10, saying what the number is from each of those inputs externally. So, if RPS is 20, it is writing the number 20 to channel 7 of this particular block. Down here, we have the XN and YN, which, as stated earlier, are not currently being used, but they're here in case I need them. And they are just outputting to 11 and 12 what the X and Y coordinates of the monitor or GPS sensor is currently. Let's see. Next, we have the touchscreen display here. This is the input for the touchscreen that we commented on earlier. This one right here. And that is outputting to several things, most of which just control these sliders. As stated, we will get into those in a minute. Camera offset is right here. It's not being connected to anything right now because it's not being used, so there's no reason to. We have the video output, which is right here to the display. It is connected to certain things, and we will explain how all of this works in just a minute. A few more things to note. We have the different gear outputs. So we have reverse right there, reverse, neutral, then first, second, third, and fourth, all being output through various systems, which I think that just about does it. A few more things that we have to talk about is we have the throttle out and clutch out, which are right here. There's clutch out, and right here we have throttle out. And again, I will explain those systems in greater detail in just a second. The first system that we are going to talk about is the loading screen before the actual display turns on. So if we spawn this in, the first thing that we are going to talk about is the loading screen. So when you turn the key, we have this screen right here with the loading bar and the explanations. That's what we're going to talk about first. Go back into the microcontroller. So right here is all of the basic logic for the loading screen. What we're looking at here is actually something very simple. We have the basic input for the system on, so when the key is turned. All right. What this is doing is going directly into an up-down counter. What this does is it counts up or it counts down based on what inputs to the block are currently being used. So system on will turn the up and down counter up, so it will start counting up, and as you can see here, increments of 0.3 with a range from 0, where it starts, to 100. Once it gets to 100, it doesn't go up any higher. What this is doing is taking that and it is outputting to channel 1 and going into a Lua script, which we will look at in just a second. We also have another Lua script, which is going into the first. And what this is that this is graphics, which is something that I cannot explain, but I will show you nonetheless. Third, we have the system on, which was talked about at the beginning, is also going into a NOT gate, which is connected directly to the up and down counter's reset. So when system on is not on, the NOT gate, sensing an off signal, is outputting an on signal, which is constantly resetting the up-down counter. Because we want that to be at 0 at all times as long as the system is off. Assuming it is on and it has gotten up to that 100, we have a threshold right here, which is looking for the number 100. The low is currently being blocked, but you can see it says low and high are 100. So it's looking for exactly 100. And what that is doing is it is switching the video signal between its off state, which is this Lua script right here, to its on state, which you can follow this back to this Lua script. And then it is outputting directly to the display. So let's look at the Lua scripts first. So this first one that we have right here is this. This, like I said a minute ago, is something I cannot explain to you. All of this is complete gibberish to me. But what it's doing, it is effectively outputting a picture of sorts. And that picture is derived from a tool that I used online and is referenced in the loading screen itself, which is pony.ide. It is a graphics to Lua translator of sorts. And what this is doing is this is going into the next Lua box, which is this one, which draws the loading bar and a few of the more specifics on top of the graphics said previously. And we have a few very basic things right here. So for starters, we have load equals input.getNumber1. What does this do? This is basically saying the input 1, so input on channel 1 equals load. What is input channel 1? If we take a quick look at it right here, input channel 1 is the number from the up-down counter, so between 0 and 100. And that is basically saying load is that number. L2 equals math.floor load. What does this mean? L2 equals math.floor input.getNumber1. So L2 equals math.floor input load, aka the number from the up-down counter. What does math.floor do? Math.floor will take the number, which, 1.100 decimals, and will get rid of all of the decimals. So instead of 1.5960 whatever, it's just 1. Load B is another variable, and that is load divided by 100 times 64. What does this do? Load B is the load bar. So if you remember, when the load screen is happening, you see the red box, which is the loading bar, and the white bar that fills it up as it gets closer to 100. That is what is controlling that variable. So load B, using some very simple math, is just counting the pixels on the screen and constantly filling up that white bar. Then we have the function onDraw. Previous was onTick, which runs every tick, aka every about 1/100th of a second. OnDraw functions at all times, so unrelated to onTick. It's way faster than onTick, but is not used for high intensity code. So function onDraw, W equals screen.getWidth. That's very self-explanatory. W equals the width of the screen. H is the same, screen.getHeight. H equals the height of the screen. Both of those at all times will equal 96 on this particular screen, because this is a 96 by 96 pixel screen. If we look below it, we have screen set color. What does this do? Screen.set color with the integers after it is using RGB values to set the color of the screen currently. So 0, 0, 0 would be white. And what this is doing is this is basically saying, what color do we want the next thing to do? We want it to be white. Currently, that's being used for nothing. It doesn't need to be there, but I have it there just in case I need to use it, and it was used previously but is no longer. Redundancy. Under that is screen.setColor 100, 0, 0. What does that 100, 0, 0 mean? Well, this is an RGB value. If you think about it, R, red, G, green, B, blue. 100, red. So it's not the highest it can go, which is 255, but it's about at that halfway point. So, a good solid red color. Not eye-piercing, but you can tell it's red. What does this do? Well, if we go down one line, we can see screen.draw text box. This is taking the coordinates on the screen and outputting a text box. So, coordinates 0, 33. 0 on the x-axis, 33 on the y-axis. The width and the height, we have w, which, if you remember, w equals screen.getWidth, and h minus 10. So h equals screen.getHeight, the screen's height, 96, minus 10. What is in the text box is in parentheses here, or in apostrophes here, and that is Squiddy OS Systems, which is just the text that's on the screen. The last two zeros are alignment. 0, 0 would be directly in the center of the text box. If you had -1, -1, it would be the top left, so on and so forth between -1 and +1. Under that, we have screen.drawRectangle. What this is doing is this is drawing the red rectangle directly under the Squiddy OS Systems. So we have the coordinates x plus 10, height minus 17. So the x and y coordinates, very simple. Then we have how big it is. So we have width minus 20, so 20 pixels away from the sides of the screen. 5 height, so it's 5 pixels high. Then under that, we have screen.drawTextBox, again, still in red. And this is just drawing L2 under the loading bar. If you remember, L2 is math floor, aka no decimals, load. Load is input.getNumber1 or input 1. And it is writing a percentage sign after that. So you're getting the percentage of the up-down counter externally from this Lua script as a percentage and displaying. Then we have the screen.setColor 100, 100, 100, which is again a shade of white. So this is just setting the next line to a color of white. Then we have screen.drawRectF. Above screen.drawRectF, we had screen.drawRect. What's the difference? Screen.drawRectF is screen.drawRectangle F full. So it's drawing a full rectangle as compared to one that is hollow in the middle. And what this is doing is this is just taking the load B, so how full the bar needs to be, and drawing the rectangle as load B as its width, so it slowly fills up the bar as loading gets closer to 100%. And then under that, we have end. So that's all that this particular Lua script does. This is just the loading screen. Very simple, not very long. Took me probably about 5-10 minutes to write. It took longer to figure out where everything needed to go on the screen than it actually did to write the code. All right. On to the next part. If we come off of the video switch box, once up-down counter is at 100, loading screen is at 100, this threshold, 100, will output a positive signal to the video switch box, changing it from off to on. This video switch box will always output to the display. That will never change. What does change is what script will be active in the switch box. So when it is between 0 and 99, it will be off, meaning the loading screen is being active. When it is on, everything else is active. So that's the loading screen explained. Now, we're going to take a step back from the next box, and we are going to go all the way down here. So first thing we're going to explain is all of the blue boxes that I just explained, or that I just highlighted. So first, we have this Lua script right here. This Lua script, ignoring the camera offset, it's not being used. This Lua script is, like above, graphics. What this is doing is this is displaying a basic picture of the display's graphics without any of the variables, none of the numbers, none of the sliders, nothing. So basically as if, a like 2005 screen with a bunch of graphics drawn on it was turned off. You know how you can still see all the words, but nothing's being displayed? That's basically what this does. Just a digital version of that. That is taking its video output right here, nothing else, and it is going to another Lua script. This Lua script is one of the 3 sliders. To be specific, this is the gear slider. Now this is the only one of these that I'm going to be explaining because the other 2, throttle and clutch, work the exact same with different outputs, and I will be explaining those. So, what is this doing? Well, if we take a look outside of the Lua script, we will see that it is getting the video input from the graphics Lua script, which we can ignore entirely because that is just displaying graphics. Other than that, it is getting an output at channel 10. So you see active channels 1, start 10, so channel 10. And what is that variable getting it from? That is the touch screen, which is the X and Y coordinates of where I am touching on the screen at any given point. This composite right is getting an input 1, aka, what is on channel 10. It is getting an input of a memory register, which is 82. Now, this will make a lot more sense once we get into the Lua script itself. This is just explaining everything beforehand. The memory register is getting its input from a clamp, which is a number between 66 and 82. Again, those numbers will make more sense in a minute. The clamp is getting its input, so it will not output anything between 1 and 65 and 83 and beyond. Anything other than that, it's a 0. Between those, it will output its number. And it is getting that from channel 4 from the touchscreen. And I will explain what channel 4 does in just a minute. Alright. This is getting quite interesting. So, what else do we have here? Coming out of the memory register, again, like we said a minute ago, we have the stored number writing to channel 10, going to the Lua script. Where else is it going? It is also going to a few expression blocks. There's one right here. We have one right here as well. Currently not connected to anything, but there is a reason for that. Then we have this expression going into a composite write, starting at channel 20, so outputting to channel 20. And that output on channel 20 is being written to this Lua script. So this Lua script will see channel 20 as the output of this expression, which is being translated from the memory register's current value. And it itself is outputting to the gearbox. So we have, if you remember, all the way outside of the microcontroller, we have the gears reverse right here, outputting to reverse, neutral, first, second, third, and fourth, outputting on specific channels set to only those. The only interesting part here is the one that is outputting to neutral. Every red node in this logic box, this microcontroller, is a Boolean value. Boolean meaning true or false. Every green node is a number value between 1 and infinity. The gearboxes in this game operate off Boolean values. So are they turned on or are they turned off? If they're turned on, they will give one ratio. If they're turned off, they will give another. Clutches have a numeric value between 0 and 1 and will basically say, how much pressure do I need to put on the line to actuate the wheels from the engine or whatever you have it connected to. So we need to figure out how to get a Boolean value from the Lua script channel to turn it into a numeric value. And we're doing something very simple, which is using a numerical switch box. And what this is doing is when it is turned off, it will display the second value, which is 1, meaning 100% on. When it is getting a positive value, it will output another signal, which is 0, which is 0% on. And it will output that to the clutch. So if neutral is off, it will be the clutch will be 100% engaged, so power can pass right through it. If neutral is on, it will output a number of 0, which means nothing can get through it. That is the only differentiating factor between neutral and every other gear. Going back to the Lua script, now that everything outside of it has been explained, we have a few basic things. So let's start with the first Lua box, which is getting the touchscreen input on, as stated, channel 10, and is getting the memory register's number as the same input. If we come in here, this is the slider. This is just the gearbox slider. So we have a few very basic things. So function on tick at the beginning here, up top. Function on tick. Input x equals input.getNumber3, which is the x coordinate coming from the touchscreen. Input y is input 4, which is getting the y input from the touchscreen. So those combined is where you're touching on the touchscreen. Is pressed equals input.getBool, a true or false value, from channel 1, which is, am I pressing the touchscreen at all? And button G is input.getNumber10. Remember that register from the outside, which is the actual button on the display itself. Under that is some very, very customized to this game specifically, but also universal Lua script, which is something you can put in here and actuate, which is basically saying, I don't want to know if I'm touching everywhere on the screen, only in these coordinates. So as long as my pointer is inside of these coordinates, output true. And right here, we're just outputting a true or false statement to channel 1, is pressing rectangle. Is pressing rectangle is right here. And as stated a second ago, it is specifying is pressing rectangle equal to is pressed, which is true or false statement from channel 1, and is pointing rectangle, input x, input y, where on the screen am I pressing? Is it inside of these coordinates? Okay. And what this is doing is this is returning true if the point, x and y, is inside the rectangle at where the rectangle is, with the width of the rectangle's width and height. If it is, it's returning true. Below that, we have function onDraw, which is drawing the slider itself. A very basic script. It's just drawing. It's getting the width and height as in the previous box. It's setting the color to a nice blue or a nice green, which is 0, 100, 0. It's drawing a line between two select coordinates on the screen where we want the slider to be. It is then drawing a red 255, 0, 0 button, and it's drawing a filled rectangle, aka the button itself, at coordinates where the button is, button G, which if you remember is input.get number 10, which eventually translates to where I'm pressing, and then how big I want it to be, which is 3 wide and 2 tall, which is right here. And if we go all the way out and look at one of the displays, letting it load, we can see the gear, that symbol right there. We have the red box and the green line, and that box will appear wherever I am pressing. Going back into the microcontroller, we have this box, which, if you take a look, is getting the memory register, its output. It is going into this expression, which is saying between pixels 66 and 82, what part of that is an output of 1 to 6. So between 66 and 82, evenly distributed, is 1, 2, 3, 4, 5, 6. This could have been done with individual variable code, but using a function is a lot easier. That is then being written out of here to channel 20, and channel 20 is being input to the next Lua script, which, as stated, is going into the gearbox channels right here. Inside this Lua script is something pretty simple. It is doing pretty much exactly what I told you a minute ago. It is taking the numbers 1 through 6, using a bit of basic math to describe if the slider is at certain points, output between 1 and 6. Now, this is getting pretty long, so I don't want to describe all of it, but that's what all this does, and you can pause and read the gray text here and get a basic understanding of what it's doing. The only differentiating factor is this code down here, which is taking values from here, that 1 to 6, and outputting them as 4 to -1, which will then be displayed on the screen above the slider itself, which we will look at in just a second. So all this is doing is just taking mapped value, and that is equal to 4 minus input value, which up here is get number channel 20 plus 1, which is going to translate to getting the numbers 4 to -1 from 1 to 6. It is then saying mapped value equals math floor mapped value plus 0.5. So this is saying the mapped value, which is equal to 4 minus input value plus 1, is equal to math floor, so no decimals, mapped value plus 0.5, which is rounding it to the nearest integer. It is then outputting mapped value, so that 4 to -1 on channel 23. Outside of here, channel 23 is being read right here, going into a composite write, which is outputting on channels 15, 16, and 17, right here. That is being put over to this larger composite write, being sent straight through to this Lua script, which we will get to in a few minutes. Just remember, channel 23 is the gear to be displayed above the slider. Now, we only have a few more things to go over, which is these two modules right here, which are not going to take very long because they are borderline the exact same, and even more so close to the exact same as the gear. So this is the exact same previous to the function as this, except instead of controlling the gear slider, it is controlling the clutch slider. Instead of outputting between 1 and 6, it is outputting between 0 and 1, and that is directly outputting to the clutch between 0% and 100% clutch pressure. And that is doing the exact same thing. The Lua is the exact same, minus or plus a few variables for the different sliders. Same thing is going on up here for the throttle. The exact same thing. Same function, different output to the throttle. Everything else is the same, minus a few variables for a different position for the slider. Now, the last two things that we're going to look at is this box right here. This is the main display control box for the entire display. So we're going to take a quick peek at where its two inputs are coming from. So if we come all the way back from the video output, we have the original video display, aka the graphical display of everything that's not being actively changed at any given moment. So like I said, the colors, the explanations, the gray background, everything like that. Its video output is going into this Lua script's video output, going straight through it to this video output, going straight through that to this video output, it's going straight through, and its video output is being sent to the main box. So what this does is it is taking the Lua graphical image from the main display here, taking it all the way through every Lua box that's used up to this point. So coming into this is now the original graphics, the slider for the gears, slider for the clutch, and slider for the throttle. All of those are now actively being displayed in the main control box. Now, where is the composite coming from? The composite is coming from this main brick over here, which we talked about at the beginning, and also just a few minutes ago from these expressions right here. It is taking the RPS, temp, fuel, and battery, and the X and Y coordinates, and channels 15, 16, and 17 for throttle pressure, clutch pressure, and what gear we're currently on. And it is outputting all of those channels to the main display box. The main display box is outputting video, once it's all said and done, which we will talk about in a second, to the original video switch box that is also being used for the loading screen, and it is outputting to the main display. Inside this main display box is the most written code, but also the easiest to understand written code. So what this is doing is we have a large amount of inputs that we're getting. So let's start at the top. function on tick, so every about 1/100th of a second this is happening. We have X in and Y in coming in at input 11 and 12. As stated, currently those aren't being used, but they're there if I need them. Next, we have RPS, temp, fuel, and battery inputting on channels 7, 8, 9, and 10. What is being done with those? If we come down to function on draw, again, at all times, updating live, they are drawing to their specified channels right on their specified point on the screen. Now, if we see these are not the same variables, fuel F is, in Lua terms and coding terms in general, not the same as fuel. So what is happening between fuel and fuel F? Fuel F is, let me find it here, fuel F right here is equal to string format, which means how many decimals do we want. String format, this little piece right here, this apostrophe percentage point 0f apostrophe, is saying that we want 0 decimal places in this output. 0 decimal places on what, though? For that, we want fuel T divided by 748, which is the amount of fuel that we have in the vehicle that this is being used on, times 100. So what this is doing is this is outputting the percentage of 748 that fuel T is of 748. What is fuel T? Fuel T is string format, same thing, 0 decimals of fuel. And that is, of course, the direct input for channel 9. And that is outputting down here in its display box as a percentage. So the display box is displaying between 0 and 100% of 748 our current fuel is. Everything else is vaguely the same. RPS, fuel, and battery are being string formatted for 0 decimals and then being output in their respective zones right here. Then we have throttle and clutch. Throttle and clutch are being input at channels 15 and 16, and then they are being sent directly through to the string formats right here, which for throttle and clutch we want 1 decimal point because it is between 0 and 1, so we want 0.1, 0.2, 0.3, 0.4, so on and so forth, to display what it currently is in their in their specific spot, which again we will talk about in just a second. The last thing that's happening here is gear. Gear is being input at channel 17. We want 0 decimals, so it's being string formatted for 0 decimals. It is then being output to its specified point on the screen. And like everything else, all 3 of those have different colors, so they're easier to understand at a quick glance. Now, let's take a quick look outside the display. And you can see where all of those are being put on the screen. Let this load up. As you can see, we have the throttle slider right here. Box goes to wherever I click on the screen, and its value is being output above here, also in yellow, for a quick glance of how much throttle we're currently giving whatever this is connected to. Same for the clutch, we have the blue. It goes up and down based on what we want. And then the gear is also up and down and outputs what gear we're currently on. Fuel, battery, RPS, and temperature are being output 0 currently because nothing is connected to them. But if we go over here to where something is connected to them, we can see that they are outputting accurately. So 24% fuel, 0 battery, technically correct. RPS of 4 per second, and the temperature 21 degrees Celsius. So yeah, that I hope was a much better explanation to this display than I could have given off the top of my head. This was done with a bit of a script that I've stuck to for the most part. And yeah, so this project has been in the making for about 3 weeks now, and brainstorming for about another 2 before that. Certainly some improvements to be made on it, but I'm very proud of it. Before this, I knew a very basic amount of Lua scripting and coding, and after it, I certainly am no expert at it, but I am more educated than I was previously, which I'm very proud of myself for. I hope you enjoyed this explanation and demonstration of what I have been working on for, like I said, about the last 3 to 5 weeks. And there will most certainly be some updates to come in the future when this is more fleshed out and perhaps these boxes work as menus for a specific craft. If you got to this point, I thank you very much. I know this has been about an hour long and was probably quite boring for part of it. But, you know, I'm very happy that you sat through and that, you listened to me explain what I've been working on. If you enjoyed, please feel free to like and subscribe and maybe comment on anything that you saw was either inefficient or could be changed. And I hope to be updating this in the future. Well, you have a good rest of your day, and I will be talking to y'all later. See ya.